All right, this is AP Calculus. So we are on Thursday. We have 2 days of review. Our final exam, our AP test is Tuesday of next week. All right, so number 4, this one should seem familiar. A particle is moving along an x-axis. Everything is differentiable. Let's talk about part A. All right, so find both the time and the position when the particle is farthest to the left. What am I doing? Table. Yes, this is the absolute minimum. So I'm going to write here in our notes, this is going to be the absolute minimum. So when it's farthest to the left, let's go ahead and make our table. So our t values are going to be over here. We're going to have start plus change, and that is going to equal to our end. All right, so what are our bounds? 0 and
3, oh, 6.
0 and 6. All right, we also need to find CVs as well. All right, because this is a graph of V, our CVs are going to be what?
What was that?
This is a graph of V, so V is kind of like the graph of the derivative of position, right?
So would it be 4? No,
So-
not 4. It'd be in between 1 and 3.
Nope. So again, if you're thinking of position, we'll think of f of x kind of as position. That means f prime of x is what? Velocity, acceleration, velocity. Okay. So this is essentially a graph of f prime. It's a graph of the derivative. What's the definition of FCV?
FCV
FCV is f prime
equals to 0.
equal to 0, which means the height on the graph of f prime is equal to 0. Where do I have a height equal to 0?
3 and 5.
3 and 5. Let's write them down.
We could just put 3 because we're trying to find the min.
Exactly. We don't need to do 5, so let's write down why we're not doing 5. We're only going to be doing 3. 3. T equals a 5, not considered.
Huh?
We're going to say T equal to 5, not considered. Why?
Because if you look at it, at 5 it goes from positive to negative from the height, and we're trying to find the min, which is from negative to positive.
Perfect. So you can say, yeah, you can say that. You can say it goes from a negative to a positive height. What else? Another thing that you can say in terms of its area?
The height's going to be positive. I mean, not the height. The ending is going to be bigger either way because it has a positive area.
Preceded by a positive area. Perfect.
Do we have to put why we don't consider that or not?
No, I'm just getting in the habit of, sometimes you don't even need to make a table. You can just make a list of bullet points like this. If you can eliminate every single option, then you're done. You don't even need to make a table. Sounds good. All right, so our integral is going to be from 0 to 0. So what is our start value?
We started 0.
Nope. Well, the
no.
time is 0.
Negative 2.
Negative 2. So negative 2 is our start value. Negative 2. Negative 2. Okay, change. What is our change?
The integral from 0 to whatever.
0 to 0 for that one, yep. So plus the integral from 0 to 3 plus the integral from 0 to 6. And this is going to be, we'll call this velocity. So just say V. V. We'll be super informal about it. That's fine.
Do we do VT?
You could say V of t if you want, like V of t.
Yeah.
If you want to be slightly more formal. If you're being super formal, you might as well put dt as well.
It's only 2 more legs.
Again, yeah, that's true. And we seem to not really be running out of time, so we can do that. All right, so the end value for 0 is going to be?
Negative 2.
Negative 2. Okay, now we actually have to calculate the area. So let's figure out what these areas are. This area right here between 0 and 3
It's negative 8.
is negative 8. How'd you come up with that? Oh yeah, so
Because it's all-
8, 3, and 2. So this is negative 8, positive 3, and this area right here is negative 2. So it's going to be negative 2 plus negative 8, which is negative 10. And then finally, negative 2 plus. Now I need to do all from 0 to 6. I need to add up all of these. Negative 8, 3, and negative 2.
So it's going to be negative 2 plus 7. I mean, negative 7.
How'd you get negative 7?
Because negative 8 minus Negative
Oh,
8
yeah,
plus 3
it is
equals
7.
negative 5. Negative 5 minus 2 equals negative 7.
But then did you get your start
Oh,
condition as well?
No, I was just telling you what the whole
Okay.
variable.
Yeah, you're right. The change is negative 7. Yes.
We had an idea. We're kind of ahead on the online. What if we took the 8th graders for
Or,
like
like,
tour
showing
around the
around?
school?
Yeah,
Let's
that's
do
a
it.
good idea. 'Cause then they don't have to
Follow
start
us.
this.
Yeah.
Nah.
The barrage of calculus.
I was like, no, yeah, don't take it.
Right. Keep us
Yeah.
above it.
Okay, we'll be back. Don't worry. Hopefully, we won't get lost.
All right. So the
Yeah,
position.
don't
It's hard.
We need both the time and the position. Time and the position. So at t is equal to, what is it farthest to the left?
3.
T equals 3. Position is farthest left. At negative 10. And I don't think there are any units, just negative 10 on the axis. Perfect. That was part A.
Can we just say t equals 3 at negative 10?
Yeah, that's fine. All right, on to part B. How many times, or for how many values of t between 0 and 6, so between this interval, is the particle at x equals negative 8?
Oh.
What do we think?
They're going to be from 0 to 3.
From 0 to 3, because it goes from position negative 2 to negative 10, so we can say at position negative 8 on the following intervals. On 0 to 3
Oh, yeah, Heather said the bells.
are all off today. On 0 to 3, what's another possible interval? We didn't calculate it, but if we put 5 right here, we can squeeze that in with a different color here. At 5, then I should be getting what position? So add 2, because we didn't have this 2, negative 7. So on 3 and 5, it should definitely hit there. So between 3 and 5. And finally, also 5 and 6. And why? You do need to say why. Because
Wait. But it's when the particle is at x equals negative 8.
yes. Why is the particle at x equals negative 8 on those intervals?
It's like you know why, but it's hard to write it down.
I will help us write it down.
I don't see that's the thing.
Okay, so do you agree that you're at position 2?
Yeah.
And now I'm at position 10.
Yeah.
Would you agree that between negative 2 and 10 lives negative 8?
Okay. I see.
There's a theorem that guarantees heights.
So if negative
We're talking about
8
heights here.
If negative 8 isn't between these two numbers. Okay.
Oh, IVT.
There it is. You need to mention IVT to get all the points here. Because the function is continuous. You do need to say it's continuous, because otherwise you're not allowed to use IVT.
We have to say continuous for any of them.
Yeah, between 0 and 6. I guess I could just say on the interval from 0 to 6. And IVT guarantees, or you can say means, if you don't like big words, all heights between I guess we can say between negative and 2 and 10, between negative 2 and 10 on, and then we do need to say the x. So I can't write my interval. I want to write my interval like this, 0 to 3, but the problem with doing that right here is, am I talking about x or y? So you have to say from 0 is less than or equal to x, which is less than or equal to 3. as well as the other intervals. And if you want to be super clear, I think we're already being really clear and getting full points already. -8 is a height. For each of these intervals. All right, and we still haven't answered the question. The original question is how many times? For how many values of t? And well, we have 3 intervals, so 3. So 3 times. Because there are 3 intervals. At least 3 times. It could be more than that, but at least 3 times, because it might have gone up and down and up and down through it on that one interval.
But we do have f prime and it doesn't.
Oh, yeah, we do have graph of v, so you're right. It doesn't do anything like that. So it's 3 times. All right, we ran out of room for part C. What is it asking for? On the interval from 2 to 3 is the... Okay, this one a few of us missed, so I do need to spend some time going over this. There's that one question last week, like, what is speed? And as soon as I saw this question, I'm like, oh, shoot. It's asking about speed, and I never went over speed again. Speed.
Is it absolute value of velocity?
So, if you're talking about speed increasing or decreasing, you have to compare your velocity and acceleration. If velocity and acceleration are the same, then you're speeding up because I'm going positive, and I'm going even more positive because the acceleration is positive. But, for example, if they're switched, like velocity is positive and acceleration is negative, that means my velocity, I'm moving forward, but I'm accelerating backwards, so I'm slowing down. My speed is slowing down. So I'm talking about speed, and I'm asking if that speed is increasing or decreasing, so you need to compare both velocity and acceleration. Is that speed increasing or decreasing? Am I speeding up or speeding down? So we need to check velocity and acceleration. Well, velocity is just height, right? What is acceleration on a graph of v?
Would it be slope?
Acceleration is slope. So, this is asking for between 2 and 3. So let me look at this. Between 2 and 3, the height is always...
Increasing.
The height is always positive or negative?
Positive.
Negative.
Oh, negative?
The height is always negative.
Oh, sorry. I thought you were talking about acceleration.
And then the slope is always positive. So on this interval, I'll even write it down. On this interval right here, we have a negative height and positive slope, which means I have a negative velocity, so I'll put velocity here, and a positive acceleration. If those are opposing each other, is it speeding up or speeding down?
Decreasing.
I mean, that's not one of the options formally, but yes, it is decreasing in speed, yes. So speed is decreasing. Speed decreasing. And it does say to justify, I believe. Give a reason for your answer. So our reason is because velocity and acceleration are different signs. So because v and a, different signs.
I think we've talked about this.
We have. I just didn't review it when you guys were asking about it last week. I think that was the day that Ben missed, and it was in the video.
So whenever they're both opposites, that's when they're always decreasing, right?
Yes.
But if, like, say both of them are negative, then it's...
I'm accelerating even faster backwards. My speed is increasing, but in the negative direction.
So what I say, like, speed is increasing?
Because they both have the same signs. Yeah.
Okay, so they have the same signs, increasing. Different opposites, decreasing.
Yeah, and if you're just talking about speed, Ben had that correct. Speed is just the absolute value of velocity. But if I'm talking about if speed is increasing, you need to compare v and a. All right, on to part D.
Wait, you forgot D.
We're doing D.
I just said on to part D.
sorry.
I'm gonna have to write it.
Okay.
Let's see. I'm sorry that I have to write it up here, but whatever. So for part D,
Weird place for it.
well, I guess I could add a new page, but I'm being lazy. So during what time intervals, if any, is the acceleration negative? Well, that's pretty straightforward. Where is it negative? Negative where it has negative height, slope, concavity,
Slope.
slope. So where do I have negative slope? I would say that it ends right there, and from here to here. So I have negative slope between 0 and 1, and I have negative slope between 4 and 6.
How do you know it's 1?
I just
It says
guessed.
1.
Oh, it says 1 actually right there.
It says 1?
Horizontal tangents at t equals 1.
Oh, okay.
So negative, or I can even write this, negative acceleration on 0 to 1 and from 4 to 6. And we do need to justify our answer. It says justify your answer. So our justification is because, and you can't use acceleration in your answer. I think one of you said, well, because the acceleration is negative. And it's like, well, the question was asking, where is the acceleration negative? Your answer can't be because acceleration is negative. It has to, that's like recursive, what is it? Loop logic, what is it called?
Anyway, you get the idea.
You get the idea. Use velocity. If it gave you velocity, use velocity in the answer. So v prime is negative, is less than 0. That is a perfect justification.
Can we just say A is negative, is less than 0?
You cannot say that, and I just said why. So you can't
Oh,
use
sorry.
A because it says where is A negative, and you're saying, well, because A is negative. So it's recursive logic. You have to say because V is negative. You were given V, use V in your answer. All right, that is all of that. Let's go on to the multiple choice, and then we can go hang out with the 8th graders. So I'm taking the derivative of, oh, I remember doing this with Rochelle already.
Oh.
So let's write out what f of natural log of x is. Those bells are annoying. So f of natural log of x, what is that thing? Well, that means I'm plugging in a natural log of x into each of these x's. So let me actually write out what that looks like. That means I have natural log of x, that thing quantity squared, plus 2 times natural log of x. That's the function that I'm taking the derivative of. So let's take the derivative now. So f,
Does it work if you instead do just d over dx of f of ln x, like you do f prime of ln x times 1 over x?
it does, but you have to remember that each of those x's when you're doing Dowder has to be the inner is still natural log of x. So yes, it will work as long as you're careful. If you do it this way, then you don't have to be careful. You just like plug and chug. You know how to take the derivative. We are probably like 4 minutes away from being done.
Nope, they're leaving.
All right. F prime of natural log of x. So now I'm taking the derivative. So the 2 is going to come down, and it's going to be 2 natural log of x. And now that was Dowder of just this thing. Now I have to do dinner. Well, the derivative of inner derivative of natural log of x is
1 over x?
1 over x. So times 1 over x. Now I'm going to do the derivative of the second part. So the derivative of that is going to be,
Natural log of x?
yeah, so it's going to be,
Because the 2 goes away.
so the 2 is still there, because when you multiply, it doesn't go away. When you add, it does go away.
Oh.
So it's 2, and then there's no inner here. The inner is x, I guess. So this is just outer, or Dowder.
So
What is Dowder?
2 over x.
2 over x, yeah. And and I guess I can combine my fractions, so
We can take out 2 over x, right?
what do you mean take out?
So like because they both have 2x, so it'd just be 2x parentheses natural log of x.
They both have a 2, so I could factor out a 2, but you notice that none of the answers have it factored out. And the answer is just a because they're just adding fractions here. They're both divided by x, so this x can be extended right here. Well, 2 natural log of x, 2 natural log of x, plus 2, all of that over x. All right, number 14, polynomial. We have the second derivative given in the table above, which must be true. All right, what is the definition of f increasing?
F of prime of x, it goes from positive to negative.
No, that's a minimum.
Oh,
Try again.
That's a maximum.
Okay, this bell has rang so many times.
Yeah.
What is it doing?
Oh,
It
it's
never
greater than
rings
0.
that many.
For increasing is greater than 0, exactly. Okay, what about decreasing? F prime.
D is less than 0.
Okay, do we have F prime?
Yes. No.
We have F double prime. Cross them out. We can't do anything because we don't have F prime. What about local max? What's the definition?
That's
F
F.
prime.
Yeah.
F prime,
Positive to negative.
positive to negative, and we don't have F prime. So it's between D and E already. All right, inflection point, definition.
F double prime
F double prime,
equals to 0.
sign change. And then concavity. So let's just assume concave up. F double prime
It's greater than 0.
is greater than 0 or less than 0. Or F double prime less than 0. One of those. All right, so to have an inflection point, it needs a sign change. So at x equals 1, it looks like it goes from a positive to a negative, but there's a problem. Look at this. 0, 0.91, 1.12. Well, I have the values for 0. 0 is 5. Maybe I should do this in blue. 0 is 5, 1 is 0, and 2 is negative 7. But what if it did this? It went 1 and 1. You don't know. You don't know if there was a sign change or not because we have incomplete information.
Right.
So it cannot be D. By process of elimination, it's E. It does change concavity between 0 and 2 because look, you definitely have a positive, you definitely have a negative, you definitely went from a positive to a negative at least once. You definitely changed. Cool, cool. And 2 more questions. So I need to take the antiderivative. Do we like fractions in this class? We don't. So I'm going to rewrite this as the integral from x times x squared minus 4 to the power of negative 1 dx. All right, so if I'm trying to go backwards, obviously this looks complicated, which means I'm using taxman. Yep, so u is going to be what? Take the most complex inner.
X squared minus 4.
Good. Taxman,
X.
x. And u prime is
2x.
2x. Whew, okay, good. Those x's canceled out. We're paying the taxman with 1/2. So this, the taxman was x, so this x now gets swapped out for a 1/2. We're paying the taxman. So by paying the taxman, we now have a 1/2 x squared minus 4 to the power of negative 1 dx. All right, so when I do this problem now, I'm going to take the antiderivative, 1/2. Okay, I need to add a power and divide down. Oh.
Natural log.
Natural log, good. Natural log. Whenever you take the natural log, you have to have
The lines.
absolute value. Exactly. Absolute value of x squared minus 4. We don't need to worry about dinner because that's what taxman did. And don't forget your plus c. That is the answer. Where is it? C.
I do see it.
Aha, I like it. All right. Last question for the video. If sine of blah, 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 xy equals x, then how do I do dy dx? Well, I'm going to just take the derivative. So, the derivative of sine
Cosine.
is
Yeah,
positive or negative cosine?
Negative cosine.
No, it's positive.
It's positive, yeah, because S stands for same.
Derivative.
Yeah, you're not going backwards, exactly. So cosine of xy, and now I have to do dinner. Ooh, dinner's tricky.
Product rule.
Product rule. Whenever you see 2 variables, and those 2 variables are being multiplied, it is always, always, always product rule. 1d2 plus 2d1. So this thing is going to be multiplied by dinner. Dinner is that 1d2 plus 2d1. 1 is x. d2, someone else do it for me.
Y prime.
Y prime plus
Why?
y, and then times 1, so just y. Okay, and that's going to be equal to, what's the derivative of x on the right-hand side?
1.
1. Perfect. And I'm solving for y prime. So let's do this. Let's divide both sides by cosine xy, and I'm now left with xy prime is equal to, or xy prime plus y, forgot that, is equal to 1 divided by cosine of xy. From there, I need to subtract y, so let's subtract y, and then move him away. And then from there, divide both sides by x, and I get, oh, it's all in one fraction. So this minus y, I need to multiply by cosine of xy on the top and the bottom. So I'm going to multiply cosine xy on the top, multiply by cosine of xy on the bottom. So my new fraction, before I divide by x, is now 1 minus, bless you, y cosine xy, all of that divided by cosine of xy. So before I divide by x, that is my new fraction. Now that I divide by x, just slap on an x on the bottom. X is equal to y, and where is my function? It looks like answer is D. Let's do the rest for homework and play with 8th graders. Sounds good?
Yeah.